Welcome. In this video we're going to discuss the answers and potential pitfalls to the P2 revision worksheet and talk through some of the questions on it. Remember that in terms of experiments you can usually get points in terms of improving the experiment by talking about something that will increase the accuracy of your data, such as using a digital sensor instead of an analog one, or using a digital measurement instead of a ruler or a measurement that might be based in human error. At question 3, these conversions will come up again and again in different topics in physics. Do remember that the key here is to make sure that your units cancel out the whole way along, and therefore that you're multiplying in such a way as to ensure those units cancel. If the units don't cancel out, for example here if we'd had miles on the top and meters on the bottom with the 1609, then because we know the units don't cancel out, we know that actually here we've done the wrong thing, and so we can reverse it and do the proper thing. So that's a way you can use of checking your answer to ensure that you've done your calculations for unit conversions the correct way. In terms of distance time graphs and calculating their slopes, or the same would apply to velocity time graphs, or really any graph that you're analyzing, make sure that you find points that are as close to grid lines as possible, if not on them, and then you take your ruler in order to ensure that you have read your data values properly, and trace those lines onto your graph, showing that you have actually done that by using points that are actually on the line. So in this case we could have used the 0, the 5, or the 10 along with the 15. Then what we ensure is that we are not having to worry about reading in between grid lines, where we might make a judgment error in terms of how much each is worth. If you have points that line up with a grid line, always use those points. At question number 9, we are asked to make a conclusion as to whether or not the driver would hit the pedestrian. You can, in fact, do this using your reaction time distance, so using your SUVAT equation, and you're able to find that you can get a value without actually the reaction time in there, and that value is larger than what you would have had, so you don't even need to do the reaction time calculation. If you had done the calculation and it was less, then you could go back through and do the reaction time, and you'd be able to see that actually you did end up with a value that was far too high for that space that was given. When drawing free body diagrams, make sure that you label your forces properly, and make sure that you've used a ruler in order not only to get a straight line for your forces, but also to get a measurement that is true. So make sure you can actually read the numbers on your ruler, and therefore you're able to use it to draw to scale. You'll also potentially be asked to calculate a resulting force, and to do that we need to rely most of the time on Pythagoras' theorem, that a squared plus b squared is equal to c squared, and this is governing the three sides of a right-angled triangle. So this would not be able to be used if we didn't have that right angle between the two forces. That finishes up the questions we've deemed difficult on this worksheet, but as always you have the full answers in the description below. If you do have any questions, please don't hesitate to ask those. We're more than happy to answer them. In the meantime, best of luck with your revision and happy sciencing.